hope your journey was fine.
Yeah, it is.
Should I assist you inside?
Yeah, sure.
Alright. The next will be waiting for you. Alright, come on in. Mr. Dexter.
Hey,
This is Mr. Dizu.
Mr. Dizu, how are you?
Yeah, I'm doing fine.
Hey, have a seat, have a
Yeah,
seat.
thank you very much.
Mr. Dizu, let me explain a bit about our progress of our project. First, you can see here dimensions for 6th floor building. You can see we have overall 30 by 100 by 4.5 and times 6, which means that we have 6th floor. And by the side view, we have 9669 by 4.5, same times 6 because we have 6th floor. Front view, we have 10 by 10 by 4.5 times 6. And total, we have 385 nodes, and we have 988 members in total. So these are the 4 figures that you can see, overview of this structure. Next slide. And here are the support that we have at the bottom of the structure. And the support type, we chose fixed support, and total we have 55 supports. Why we chose fixed instead of roller is because if roller, it will move horizontally. So fixed, it will be fixed there. So it will be stable. Next slide. So for the material and property, all the members is steel, and all beams are UB 914 by 419 by 388, as you can see here. Next. And then first floor we have UC 356 by 406 by 55. Why we have a different properties for each column for each floor is because each floor they will experience different type of load force, and then we want to achieve the cheapest price that we can get, but at the same time we can get the most stable and safe structure. That's why every floor we're using different type of column. Next slide. You can see here this is for 3rd and 4th floor. This is 5th and 6th floor. So in total we have 3 types of load. The first one is vertical load, and then you can see here it's uniform distributed load, and it's negative 20 kilonewton. Why is it negative? It's because it's going downward. Next. And then you can see here we have the self-weight load. It's negative 1.2 factor. Slab weight load, negative 0.5 kilonewton in Y direction, which means in this direction. And we have floor load, negative 15 kilonewton per meter square with maximum 27 meters in Y direction. Again, the 27 in Y direction is the 6th floor. Next. So this is the horizontal load, and then we're assuming the wind load, and it goes to 1.5 and negative 1.5 factor in Z direction with maximum. Yeah. So previous slide. So previous. Okay. So you can see here this is an illustration of how the force will be going, the wind going through the structure. Next. So we have the last one, which is combined load, which combines the first and the second one, the horizontal and the vertical. So you can see here the illustration of the force. Next. And in this structure, you can see here we have 2 small red columns. Those columns are called critical member. For horizontal load, you see, as you can see here, we have an illustration of the forces. And again, we can see 2 columns are red, which means the critical members. For your information, that those members are the same members that we have for vertical load. Next slide, please. And here is the bending moment and also shear force diagram for those critical members. And then lastly, we have combined load, which means that vertical combined with horizontal. Again, we have 2 critical members, which are still the same throughout the whole process. Next slide. And here we don't have any value for our bending moment and also shear force diagram, is because when we combine vertical and horizontal, it actually makes the structure to become stable. So if we have either one of it, it will not be stable. That's why we have critical members. But when we combine both, that's when the structure will become stable. That's why we don't have any value for this. Yeah, so that's all for all the explanation. Thank you, Dizzle. Do you have any questions that you want to ask?
Mr. Dexter, I have another doubt. Why do we use the British standard beam and column for this structure?
Why we use British standard for both column and beam is because when it comes to the real construction side, it is actually easier for us to weld those beams and columns.
Mr. Dexter,
Yeah.
I noticed that for different stories, there are different properties for the columns. Can you explain why there are different properties for the columns?
So we've run through some analysis, and we realized that if we applied load on it, we actually found out a lot of failed members. But in order for us to make this structure safe, we have to use higher properties for the column. But if we use every column using the higher property steel, it actually will cost us a lot. That's why we analyze level by level, and then each level we try to find the cheapest and the most suitable column to be used. Yeah.
Thank you very much, Mr. Dexter. I hope that you will keep me up to date with this project so that this project will be completed soon.
Okay, looking forward to that.
All right. Refreshments?
Yeah, sure.
Sure.
Come on.